Good evening all of you. In this video we are going to see class 10 polynomials exercise 3.3. First question, find the zeros of the following quadratic polynomials and verify the relation between the zeros and the coefficients. So this is the continuation of our previous video. So before watching this, once try to watch that video. The link for that video is given in the description box. Okay, so after watching that, please try to do these sums. So the first one is x square minus 2x minus 8. So if we observe this, if we compare this with our general form, we can easily say that a is equal to 1, b is equal to minus 2, and c is equal to minus 8. So now we will try to factorize this polynomial using splitting of middle term method. So for splitting of middle term, what is the middle term? Minus 2. We need to split this minus 2 into two parts. So how these two parts should be? Okay, these two parts, if we multiply them, we should get a into c. What is a into c? 1 into minus 8, that is minus 8. And if we add these two, we should get minus 2. So in order to get 8 minus 8, we have 1 8s are 8 and 2 4s are 8, right? So if we add these two, there is no scope of getting minus 2, so this is eliminated. So next we have 2 4. If we add these two, if we want to get minus 2, the 4 should have minus 4. So 2 plus minus 4 is minus 2, and if we multiply this 2 into minus 4 is equal to minus 8. So it is satisfied. So we need to split minus 2 as 2 and minus 4. So this implies splitting this middle term x square plus 2x minus 4x minus 8. So minus 2x is written as plus 2x minus 4x. So now from these two terms we can take x as common term, x plus 2x, and from these two we can take minus 2 as common. Sorry, here x will not be there. So from first to two terms, taking x as common, we'll get x plus 2, and next to two terms we have to take minus 2 common, we'll get not minus 2, we have to take 4. Okay, so if we take 4 common, we'll take x plus 2. So now in these two we have x plus 2 as common, so we'll get x minus 4. Okay, so this is the factorization. These are the factors of our polynomial. The zeros of p of x are given by p of x equal to 0. That means x plus 2 into x minus 4 is equal to 0. Okay, that means the product of these two is equal to 0. That means one of this is equal to 0. So if x plus 2 is equal to 0, that implies x is equal to minus 2, and if x minus 4 is equal to 0, x is equal to 4. So these are the zeros of our polynomial p of x, minus 2 and 4. Hence the zeros of x square minus 2x minus 8 are minus 2 and 4. Okay, now we'll try to see the relation between coefficients and zeros. So we'll try to do this relationship here in this place. See, we have the relation as what is sum of roots? Sum of zeros. Sum of zeros is minus 2 plus 4, that is nothing but 2. And we know that sum of zeros is nothing but equal to minus b by a. So what is b? 2, minus of minus 2 by a is 1. So this is nothing but equal to 2. So we got both as 2. So now we can do product of zeros. That is minus 2 into 4 is minus 8. So we know, we have seen earlier that it is equal to c by a. So what is c? We have it as minus 8 by 1 is nothing but equal to minus 8. So hence we can easily say that sum of roots equal to minus b by a, and product of zeros is c by a. Okay, we'll go to the second bit. The second bit is 4s square minus 4s plus 1. Let p of s is equal to 4s square minus 4s plus 1. So for this there is no need to do splitting of middle term. We can directly do this using formula. We can write it as 2s whole square minus 2 into 2s plus 1 square. Okay, so this is in the form of a square minus 2ab plus b square. So we can write it as, this is in the form of a square minus 2ab plus b square. So this is nothing but equal to a minus b whole square. So this can be written as 2s minus 1 whole square, or 2s minus 1 into 2s minus 1. Okay. So therefore the zeros of PS are given by P of s is equal to 0. So this is nothing but we can do it as 2s minus 1 into 2s minus 1 is equal to 0. So 2s minus 1 is equal to 0. That implies 2s is equal to 1. S is equal to 1 by 2. So this is the zero value of this polynomial P of s. Okay, it has only one zero value. Okay, so next we will try to compare the zeros with the coefficients. So we will try to do it here. So we can say that a is equal to 4, b is equal to minus 4, and c is equal to 1. And what are zeros? We can easily say that 1 by 2 and 1 by 2, right? So sum of zeros is equal to 1 by 2 plus 1 by 2. That is nothing but equal to 1. So if we do minus b by a, what will get? Minus of b is minus 4 by 4. That is 4 by 4, that is equal to 1. So sum of zeros is equal to minus b by a, and product of zeros. Product of zeros is equal to 1 by 2 into 1 by 2. That is 1 by 4. And we c by a. C is 1 and a is 4. So product of zeros equal to c by a. Okay, we are able to prove that. So we will do the third bit. So the third bit is 6. We will take it as, let p of x is equal to 6x square minus 7x minus 3. So in order to do this, we have to split the middle term. So what is the middle term here? Minus 7. Splitting minus 7 into two parts. Okay, if we add, we have to get minus 7, and if we multiply these two parts, what we have to get? 6 into minus 3, that is we have to get minus 18. Okay, so 7, we have to get 18. 18, when we'll get 1 18s are 18, 2 9s are 18, 3 6 are 18. So here this first option, if we add, there is no scope of getting 7, and this is also there is no scope of getting 7. Here the second option, if we add 2 and 9, we are able to get 7. So if we take this as minus 7, 2 plus minus 9 is minus 7, and what is 2 into minus 9? This is nothing but equal to minus 18. So this is the correct pair to split minus 7. So splitting this minus 7x, 6x square, we should take 2 and minus 9. So plus 2x minus 9x minus 3. Okay. So this implies from these two we can take 2x as common. What you will get if we take 2x? 2 3 is 6. So 3x plus 1. From these two you take 3 as minus 3 as common. You will take 3x plus 1. So from these two we can take 3x plus 1 as common. So 2x minus 3. So therefore the zeros of p of x are p of x is equal to 0. So that means 3 of x plus 1 into 2x minus 3 is equal to 0. Product of these two equal to 0 means one of this should be equal to 0. Okay, that means 3x plus 1 is equal to 0 or 2x minus 3 is equal to 0. If this is equal to 0, 3x is equal to minus 1, x is equal to minus 1 by 3. If this is equal to 0, 2x equal to 3, x is equal to 3 by 2. So these are the therefore zeros of p of x are minus 1 by 3 and 3 by 2. Okay. So now we'll do the relation between zeros and coefficients. Okay. So what are the coefficients? A is equal to 6, B is equal to minus 7, and C is equal to minus 3. Okay. Sum of zeros. Sum of zeros is minus 1 by 3 plus 3 by 2. So we can, what is the LCM here? LCM is 3 to the 6. Minus 1 into 2 minus 2 plus 3 into 3 9. So minus 2 plus 9 is 7 by 6. So this is the sum of zeros. So what is sum of zeros? Minus b by a. Minus of b is minus 7 by 6. So minus into minus plus 7 by 6. So we got both equal. So now next, product of roots. Product of zeros is equal to minus 1 by 3 into 3 by 2. Cancel 3 and 3, we will get minus 1 by 2. So we will do C by A. That is equal to, what is C here? Minus 3 by A is 6. 3 1s are 3 2s are. So we are getting minus 1 by 2. So here again we are able to prove that sum of zeros is equal to minus b by a, and product of zeros C is nothing but equal to C by A. Okay. So in the textbook we are having 3 more bits. You all try to practice those 3 bits on your own. If you have any doubts, please try to comment in the comments box, right? Thank you.